Moving into chapter 2. So in chapter 2, modeling distributions of data, we're going to focus on percentiles as well as the normal distribution, which some of you should have experience with. So section 2.1, where we're going to start describing location in a distribution. First thing to talk about is a percentile and what a percentile is and how we deal with that. So one way to describe the location of a value in a distribution is to tell what percent of observations are less than or equal to it. For example, the p percentile of a distribution is the value with p% of the observations less than or equal to it. So you see percentiles frequently. You might see it when you go to the doctor's office and they say, okay, you're at the 75th percentile in height. What does that mean? That means that 75% of people are at your height or below. Or you go ahead and you take a standardized test. And on your standardized test, you score in the 98th percentile. That means you did at least as well as 98% of people. Or only 2% of people did better than you. So it's important that you understand how to interpret that percentile. So let's look at our first example. I'm going to do this one actually at home. Jenny earned an 86 on her test. How did she perform relative to the rest of her class? So we're looking at a stem plot here. Here's 86. In order to determine how she did, we want to see how many of the scores are at or below her score. Okay? So if we count how many there are here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 out of the 25 scores are hers or below. So that means that she's 0.88 at the 88th percentile. And it's important that you're able to interpret these results as well. Okay, so she's at the 88th percentile. So Jenny's score is at or above 88% of the class. Moving on, we kind of talked about what a percentile is. It measures the location in a distribution. And keep in mind, to the second part of this question, if you're at the 88th percentile, it doesn't mean you got 88% of the score of the questions correct, say on a test. It just tells you where you are located relative to the rest of the distribution. We'll hit the next example in class. Next thing that we have to talk about here is what's called a cumulative relative frequency graph. Not sure what this is doing here. Okay, a cumulative relative frequency graph displays the cumulative relative frequency of each class of a frequency distribution. There's an example. If you want to kind of try it on your own, you can do that. But we're going to look at this example in class dealing with the NBA points per game. See if you can do it though. And then when we get in class, we'll take a look at it. Moving on. One of the most important things in statistics is something that's called a z-score. Z-score really, really important. Okay, so let's get the definition of what that is. A z-score tells us how many standard deviations I'm going to abbreviate standard deviation as SDs. From the mean, an observation falls, and in what direction? So we call a z-score the standardized score because it standardizes between any distribution. I can use it to compare distributions. So if x is an observation from a distribution that has a known mean and standard deviation, the standardized score of x, and this is our formula for z-scores, z is equal to x minus the mean divided by the standard deviation. Or using a symbolic notation, z is equal to x minus x bar over sx, where x represents your individual observation. Another example that we'll look at in class, but let's talk about how to interpret a z-score if they have units and what the sign tells us. So first thing, like we just said, a z-score tells us how many standard deviations above or below the mean the observed value is. Z-scores do not have units. And finally, a positive z-score means that you're above the mean. A negative z-score means that you're below the mean. And a z-score equal to 0 means that you are equal to the mean. You're exactly at the mean. So your z-scores can be positive, negative, or equal to 0. More examples that we'll look at in class. If you want to take a look at them and try and do them ahead of time, feel free. Final thing in this section that we have to talk about is transforming data. Okay, so transforming data is another thing that we have to deal with. It's kind of separate from our discussion of z-scores and percentiles. So transforming converts the original observations from the original units of measurement to another scale. Transformations can affect the shape, the center, and the spread. So what we're going to be seeing here is we're going to be doing things such as, okay, I want to add 10 to every observation. How does that affect the mean? How does that affect the standard deviation? How does that affect the shape? Or, for example, I want to convert from inches to feet. So now I'm multiplying by something. How does that affect the shape, the center, and the spread? Well, adding or subtracting a constant changes the measure of location such as the quartiles, and measures of center, such as the mean and the median. So say I have my set of data and I want to add 10 to every observation. That's going to affect where the mean and the median are, as well as where my Q1 and my Q3 are. It does not change the shape of the distribution or any of the measures of spread, such as the range, the IQR, or the standard deviation. Okay, because all I'm doing is I'm shifting my observations down. So they're still going to have the same range. When I subtract the max minus min, it's still going to be that same individual number. Okay, so addition and subtraction only affects those measures of center. Multiplying or dividing. So now say I multiplied all of my observations by 2 or something like that. Will change the measures of location, center, and spread by whatever that value I'm multiplying by. So whatever that value C that I'm multiplying by, all of those things, standard deviation is going to be multiplied by C. Range is going to be multiplied by C. The mean is going to be multiplied by C. Q1 is going to be multiplied by C. So everything changes when we're multiplying or dividing except for shape. Shape is not going to change at any point. Okay, so addition and subtraction only affects measures of center and location. Multiplication and division affects both measures of center and location and spread by multiplying by C. We've got a lot of examples that we'll look at in class, but that's it for the notes that you have to take it home. See you guys.